Welcome to Complex Numbers and Roots. Today's objectives are to perform operations with pure imaginary numbers and to perform operations with complex numbers. So we want to start out today's lesson by talking about the imaginary number I. Now, I is an imaginary number because it doesn't exist on a real plane. Now, we're going to define I squared as -1. This is a definition. This is the definition of I. So what we can do with that is we're able to figure out the square root of a negative number, which is imaginary. So if I have I squared and that equals -1, and I want to get I by itself, if I take the square root of both sides, I have I equals the square root of -1. Now these two are the big concepts to start out with for this section. This is what we're going to use for complex numbers. So we know that I squared is going to equal -1 because that's our definition, and then we can derive from that that I will equal the square root of -1. Now this is really helpful because now we can express some square roots with negative numbers in terms of I. So let's deal with this first problem here, 3 times the square root of -16. And we want to express this in terms of I. So the first thing we want to do is rewrite this expression while factoring the negative number out of it. So whenever you see a negative number under the square root, you're going to rewrite this as -1 and then whatever number that was. Now we know that from our definition in the previous slide that the square root of -1 becomes I. So this will be 3i times the square root of 16. Now we know the square root of 16 is just 4. So now we have 3i times 4 as our expression. And we simplify that, and we get 12i. Remember, this is not a real number. This is an imaginary number. Okay, for example B, we have -1 times the square root of -75. So same deal. So we have our -1 on the outside. We want to take out the -1 from under the radical and then deal with the square root of 75. So we know the square root of -1 is I, so this becomes -I, and then we can break down 75 to be the square root of 25 times the square root of 3. The square root of 25 just becomes 5. Keep the negative on the outside. We have 5i times the square root of 3. So I helps us take the square root of negative numbers. Alright, now let's work on a few more practice problems. So for this first example here, we would take the I out first and then have the square root of 12. So we can break down the square root of 12 to be the square root of 4 times the square root of 3, and that can become 2i square root of 3. Let's work on example B. So we start off with 2 on the outside. Then we have a negative under the square root, so we take that out. Then we're just left with the square root of 36. Now we know that the square root of -1 is just I, and the square root of 36 is 6. Then we can simplify this to be 12i. And this is some more examples of how we can use I to help us find the square roots of negative numbers. Usually when we're solving for a quadratic, we're looking for the x-intercepts. The x-intercepts are our solutions. So we can see that some parabolas, they don't cross the x-axis, so therefore there's no real solutions. So oftentimes we're going to have to find the solutions using imaginary numbers. Let's find some imaginary solutions. So for this first equation here on the left, we have x squared equals negative 81. So the first thing we have to do is get x by itself. To do that, we have to take the square root of both sides. When we do that, the left side becomes x, and the right side is going to become plus or minus the square root of negative 81. So we don't like negatives under our radicals, so let's get rid of that negative under the radical. So we have plus or minus, we'll take the I out, and then we have square root of 81. Now we know that the square root of 81 is just 9, so our answer here is plus or minus 9i. Now the reason we have a plus or minus is because 9 times 9 could be 81, but negative 9 times negative 9 could also be 81. So we take that into account when we use the plus or minus. Alright, let's work on problem B. For problem B, we have 3x squared plus 75. We want to get x squared by itself, so we do 3x squared and we subtract 75 from both sides. So we have 3x squared equals negative 75. Here we want to get x by itself, so we divide both sides by 3. So when we do that, we get x squared equals negative 25. Same deal as problem A. Now we have x squared, we want to isolate that. So we take the square root of both sides. When we do that, on the left side we end up with x. On the right side, we end up with plus or minus the square root of negative 25. So we have to simplify that radical. So we take the I out with the square root of 25. We know the square root of 25 is just 5. So the answer is plus or minus 5i. Alright, let's do these first two practice problems. So for problem 2a, we want to get x by itself. So take the square root of both sides. We have x equals plus or minus I square root 36. Get x by itself. X equals plus or minus 6i. Okay, for problem B, we want to get the x squared by itself. So we subtract 48 from both sides. When we do that, we're left with x squared equals negative 48. We want to get the x by itself, so we take the square root of both sides. Then we're going to get x equals plus or minus I root 48. Now we have to break up the square root of 48. So we have x equals plus or minus I square root of 16 times the square root of 3. And we do that because we know that 16 times 3 will give us 48. We know the square root of 16 is 4, so we're left with 4i square root of 3. So today we talked about complex numbers, we talked about we talked about imaginary solutions, and we solved some equations and found some imaginary solutions. And that'll be the end of our video for today. Thank you and take care.